Hello everybody and welcome to the Math Hive. Today I'm going to teach you the core concepts you need as well as the approach to take with trig problems and how you can manipulate concepts to benefit you. Almost any trig problem on the SAT uses a combination of angles and sides requiring multiple functions. The standard things you should know are the Pythagorean theorem, SOHCAHTOA, that's your sine, cosine, and tangent, trig identities, that's your common identities such as sine squared plus cosine squared equals 1, or sine of x is cosine 90 minus x, things like those. And lastly, angle identities, such as your vertical angles, corresponding angles, and your complementary angles. While there are some problems that require heavy thinking, most problems can be solved with these four basic concepts. In fact, most of these are only going to end up using SOHCAHTOA. Now that we know everything we need, let's get into solving some problems, figuring out how to approach them, and how to do it as quickly as possible. So this question is a fairly simple one, but people who struggle to approach problems the right way and make connections quickly may get this question wrong, or get it right but take too much time. So let's go ahead and read the problem. Triangle ABC and XYZ are similar. What is the value of sine of z? And our possible answer choices are 4/5, 3/4, 3/5, and 2/3. Alright, z is an angle in our second triangle, and the question wants the sine of z. This is easy for everyone who knows SOHCAHTOA. The sine of an angle is the opposite side length, so that'd be this side here, over the hypotenuse, which is this side right here. However, we don't know the length of any of the sides on this triangle. They didn't give any of that information to us. This is where the approach comes in. If you get stuck like this where you don't have the information you need to look at the question for other pieces of information. One key piece of information here that they gave us is that both of these triangles are similar. Okay, triangle ABC and XYZ are similar. That means that the sides may be of different length. Like this side right here is not the same as the length of this side right here, but all the angles are the same. Angle A is the same as angle X. Angle B is the same as angle Y. And angle C is the same as angle Z. So this is where the connection comes in. We need to find the sine of Z. But the only thing we know about Z is that it's equal to C, right? The angle Z is equal to the angle C. When we realize this, we can make the connection that because Z is equal to C, then that means the sine of Z should equal the sine of C. If the angles are equal, then their sines should be equal as well. And of course, we can find the sine of C by taking the opposite over the hypotenuse. That means the sine of C is equal to 9/15, or after simplifying that becomes 3/5, and 3/5 is also sine of Z, because sine of Z and sine of C are the same thing. So that makes our answer 3/5. This question is a little bit tougher because they gave us way less information and they tried to throw us off with our answer choices. As a word of advice for any SAT question, or any exam question for that matter, the answer choice saying that the answer cannot be determined from the information given in the question is usually a trap, and unless you are certain about this answer, don't pick it. So let's go ahead and read the problem. The three angles of a right triangle have measures G, H, and 90. What is the value of sine of G minus cosine of H? And our possible answers are 1 over the square root of 3, 0, the answer cannot be determined, and -1/2. So we are once again given a question with SOHCAHTOA, our sine, cosine, tangent, except we barely have any information this time. We don't know the angles or the sides, all we know is that this is a right triangle. Let's try and approach this to make things easier for us. One of the first things I like to do with these questions is to create a visual if they don't give me one. So they haven't given me a triangle, but I like to make it anyway. So now that we can visualize the triangle, it might be easier for us to solve the problem. Let's go back to what the question asked. It wanted to know what the sine of G minus cosine of H was. Since we don't have any other information to go off of, this is the best place to start. We don't know the value of g, nor do we know any of the side lengths. The only thing we do know is that the sine of g is whatever this side is, the opposite side, divided by the hypotenuse. We don't know what these sides are, we don't know what their lengths are, but we can name them, just so we can keep track of things. Let's name this side A and this side C. And since sine is opposite over hypotenuse, that makes the sine of g A, which is the opposite side, over the hypotenuse, which is C. So this is what the sine of g is equal to. Now let's look at the cosine of h. Once again, we don't have much information, but we do know that the cosine is the adjacent divided by the hypotenuse. For this triangle, that is A divided by C, the sides we gave names to. Because our angle H right here, if we took the cosine, its adjacent side is A, and the hypotenuse is C. So that means the cosine of H is equal to A over C. This is where everything clicks. The sine of G is A over C, and the cosine of H is A over C, meaning that they are the same thing. No matter what the angles are, no matter what A and C are, sine of G and cosine of H are the same thing. So if we subtracted them, just like the question asked, if they're the same thing, that just equals 0. The main approach here that got us to the answer was being able to visualize the question by drawing the actual right triangle and naming the angles, and going off of every bit of information we knew about the question, including what the definitions of cosine and sine were. When we started thinking about what the values actually equaled in this triangle, what they were actually looking at, we made the connection that they were the same exact thing. And because they are the same thing, when you subtract them, you get our answer of 0. I hope you guys enjoyed this video looking at solving trig problems. If you would like to see more of this topic or another video, leave a comment below. Thank you for watching.